In number 16, we're talking about Mario's car, which costs $15,000 and it depreciates, which means goes down at 19%. How they're getting this formula is by saying 1 minus 0.19, 19% goes in for B. So you get y equals 15,000, 0.81 to the x. That's how they're getting their formula. They call t and x. It means the same thing. But now they're asking which of these is equivalent. The reason why number 2 is equivalent is because I can rewrite this as 0.9 squared and then to the t. I can do this because one of our rules says that when you're raising a number to an exponent, that you multiply these together. So if I'm multiplying, I can go backwards and say squared and then to the t power. Now, inside this parentheses, I perform the order of operations, and I do 0.9 squared, and I get 0.81. So this is how those two are equivalent. Number 17, the highest possible grade for a book report is 100. The teacher is deducting 10 points for each day. So day 1's 100, next day is a 90, then it's an 80. See how all of these are going down by 10? This is a constant rate of change, so I'm going to say linear. In number 18, the function h of x is graphed and the function g of x is given. This is not graphed, so I'm going to type this into my calculator, and I'm going to do 2 times the absolute value of x plus 4 minus 3. Go to table, and then I am going to plot these points. -7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, -6, 1. So this is g of x now. So which of these are true? I would agree that g of x has a lower minimum than this one. That is true. Roman numeral number 2, is h of x less than g of x? Is it below it or is it above it? I'd say it's above it, so it's not less than, it's actually greater than. This is false. In Roman numeral number 3, for any value of x, these two functions will not equal each other. That means they will not intersect. Okay, this is true. It looks like these are going to be parallel. So 1 and 3 only. The zeros of this function are, now I'm going to put this into my calculator, and then I'm going to look to see where this graph crosses the x-axis. Remember, the zeros are the x values where the graph crosses the x-axis. I see 0. Let me do a zoom 6 here. Let me take a look. It looks like 0, 2, and 3. 0, 2, and 3, so you should have number 3. For number 20, it says, how many of these equations listed below represent the line passing through these 2 points? To start, I am going to get this first equation in standard form by subtracting 5x, so I get this. So in my y equals, I am going to do -5x plus 13, and then I'm going to go to my table. I want to see, does 2, 3, and 4 negative, or excuse me, 2, 3, and 4 -7. Those 2 points, so I'm going to say yes for this one. For the second one, what I'm going to do is subtract 7 and subtract 7. Now, you're probably tempted to simplify. Well, you don't have to enter it into your calculator simplified. I could do negative 5x minus 4 minus 7. Go to my table, 2, 3, and 4, negative 7. Second one, yes. I'm going to do negative 5x plus 13. And guess what? Negative 5x plus 13 is the exact same thing we got in the first one, so we know it works for that one. For this one, I'm going to add 7 to the other side, and like I just said a moment ago, you don't have to put it into standard form. You don't have to simplify it to put it in your calculator. So if I do this, I go to table, 2, 3, and 4, 7. Notice how they're opposite signs. So no, we're going to say that 3 of these equations. In number 21, we're talking about the virus growth of the Ebola virus and the SARS virus. Now, what I did here, based on the information, is I know that there is one case of Ebola and is growing at an 11% rate, and then SARS has 30 initial cases and is growing at a 4% rate. So what I'm going to do is, it says at day 10 there are more of this than that, and at 53. So I'm going to evaluate all 4 of these expressions using my calculator. So to show you what I did 1 times 1 plus 0.11 to the 10th. I get 2.83. I do 30, sorry for the glare, I do 30 times 1 plus 0.04 to the 10th. Okay, so I get 44. So based on all these calculations, you'll notice that at day 10 there are more SARS, but at day 53 there's more Ebola virus.